All right, now we're going to get into piping and instrumentation diagrams. Piping and instrumentation diagrams. So here's the first time I'm going to teach you this terrible, terrible term called piping and instrumentation diagrams, P and I D. P and I D. Now, I want to make sure you're very clear on something. Piping and instrumentation diagrams, that's a diagram. It's like a pneumatic diagram, hydraulic diagram, wiring diagram, sort of, but it's a combination of several things. It's sort of like a layout diagramming, but it's not really. It's sort of like a wiring diagram, but it doesn't show wires. It's sort of like a hydraulic diagram, but it doesn't care about the actual flow of anything. It is a specific diagram that's primarily used in the process industry, continuous or batch process industry, and its whole job is to describe how the process works in conjunction with the control elements and instrumentation. And it shows the pipe connections, which is why it's called the piping and instrumentation diagram. It is unique to our industry. It's a very special diagram for us. P and ID. But I also want to mention there's another thing with a very similar term that has to do with control. We talked about proportional control, but most commonly used in industry is a three kind of control wrapped into one: proportional, integral, and derivative. And together they stand for PID, or PID stands for proportional, integral, and derivative control. They're used together. So sometimes you're going to see PID in reference to a method of controlling. Okay, and actually PID is a method of control. It is a philosophy of control. It is also something you program inside computers to do the controlling. It is not the same as a P and ID. So I just want to emphasize that strongly so you guys don't get confused, and it may or may not end up on a test question. Probably it will. So piping and instrumentation diagrams are something that's more of an acquired skill. We're going to go through some of these in the class, and we're going to look at what different vendors have provided. I think I've got a copy of an old P&ID supplied by Hershey Foods that was somewhere the previous mechatronic instructor worked. So there's a lot of different ways of diagramming process, piping and instrumentation. And that diagram can be sometimes specific to an individual company, but there's also some national standards. For instance, ISA. ISA is your biggest and most important standard for P&IDs. International Society of Automation, ISA. They're one of my favorites. They have a good, strong organization, plus training program and certification. So let's dive into this. And I'm going to dive into it a little bit and try to talk about it. A typical P&ID, and let's zoom in on this here a little bit here. This is a typical P&ID. You're going to see some things which are tanks and pipes and pumps, things that have a specific real-world reflection. And they usually lay them out on these diagrams just like they might be laid out in the real world. They're not meant to be a layout drawing, but they're meant to be shown in the diagram in a way that's easy to recognize based on the shape of what this thing on the diagram is, what that actual thing is in the real world. For instance, this thing with a slightly curved top, they've labeled it as a recirculation tank. So we can probably guess that this is a large tank. It's showing it's actually below grade. It's in a sump, so it's actually sitting about a foot below grade, 1 foot 5 inches below grade. So it's sitting down in a sump. It gives me a reference number for that tank. So if I look up that reference number on the architectural drawings, it'll tell me how big that tank is. But notice this drawing doesn't tell me what that tank is made of, how big it is, what it actually looks like. It just shows me a big rounded top box. It tells me it's a recirculation tank. It also shows me connections to that tank. Each one of these connections is either a pipe leading into the tank or coming from the tank, or an indication that that tank was penetrated by some device. For instance, a device that you might put on a tank is a device to tell you how much goop, water, or liquid is in that tank. This tank has got something that attaches at the top and then at the bottom. This little symbol here that looks like a bow tie, that is a classic manual valve symbol. It shows me a number on there, 1 inch, so that's a 1-inch valve. It shows me a line leading up to a little circle. That little circle has very specific meaning. In this diagram, that circle means that there's some sort of instrument there. And each code in that instrument means something. And there's usually a 2-letter code, sometimes 3-letter code that tells me what that instrument is. That is an LG, which means it's a level glass. That means it's a long tube of glass that shows me, by the fact that it's got a pipe hooked to the bottom and a hook to the top of the tank, it shows me how much material, how much liquid is in that tank. Because the liquid will rise up in that level glass to show me. So this is laid out just like a real level glass might be laid out on the side of the actual tank. It's roughly shaped like the tank it's meant to look like. But it's just showing you the connections and the instruments, right? So it will show you a pump symbol. Actually, that's not a typical pump symbol. A typical pump symbol will be a little bit different than that. A typical pump will look like this one down here. This being a metering pump, they just gave you a weird ass metering pump symbol and then labeled it clearly, which is okay as well. You will see dotted lines as well as solid lines. Dotted lines have very specific meaning as well. And you'll see that they mean they're a certain type of electrical or pneumatic connection, depending on the kind of line. And then you're going to see 2 instruments, one on top of the other. We see an AIC and we see an AT, right? These all have different meanings to what that instrument is. The number below is the reference number for looking up what that instrument really is. So you always have a 2 or 3-letter code that tells me what that is, and then a reference number to tell me how to look it up in your documentation. So here you can see I can find valves, I can find instruments, I can find tanks, I can find pipes, and the secret is I just have to know what all these silly symbols mean. I have to know how to look up these 2 and 3-letter codes. I have alarms as well. For instance, right here, you've got an IA. I stands for current, like just like you'd find current in amps in your other electrical classes. IA is a current alarm, and you've got an IH and L, which is a high and low current alarm. So if you have too much current going into the pump, in other words, a pump has too much back pressure or has too much resistance, it will set off an alarm before it burns out the motor for that pump. That's an example of an alarm. You have a flow transmitter, which is usually looked to a flow element. An element is what you're actually, that's your meter, that's your electronic meter on the flow of a liquid. In this case, it's sitting right on top of that pipe coming out of that pump. So I'm measuring the flow out of that pump, and I'm sending a signal to a transmitter. This is a dotted line, so it's probably an electrical signal. And that flow transmitter then sends it to an input on your PLC. And that input then would determine what to do with that flow information. It'll let the control system know how to do with it. And so you're going to see a lot of different kind of elements through the PNID that tell you how that whole control system operates. So there's no way to teach you guys how to do this stuff without going through example after example. So I want you to read through the book here, learn about the examples they give you: temperature control, flow control, level control, that sort of thing. These are all different things you can control in a manufacturing environment. Read about all these different controls, and then when we get into the classroom, we're going to go through a few examples there as well. All right, I haven't really highlighted anything in this because there's no one set of terms which you have to learn. You just have to figure out where to look stuff up. And I'll give you a hint. There's a lot of good places to look stuff up here in the back of the book. And when we start trying to interpret our PNIDs in the lab, I expect you to be able to look stuff up from this book and figuring it out. And if you don't know what those terms mean, those 3 and 4 letter terms, then we can start looking those up as well. On this page, 665, it gives you a great chart for looking at the first, second letter and modifiers for those 3 and 4 letter, 2 and 3 and 4 letter terms associated with instruments. So this is a great way of looking it up. If you have to look anything up, you can find it in here. So I'm just reminding you in the appendix. Now in this book, the appendix that I'm talking about starts on 665 and runs to 666. And I assume in version 6, it might be on a slightly different page number.